You know, I think if I knew more about the principles of aerodynamics, I'd be in a better position to design airplanes that actually fly. Well, the same thing is true about learning. The more you know about how learning happens, the better able you will be to design instruction that flies. And that's what this module is about. It's about the principles that govern the act of learning. Now, this is not a theory module. This is a practice module. What you're going to do is practice recognizing the correct and incorrect application of a variety of learning principles. Now, to get started, let's think a few minutes about the thing that actually does the learning. And that's mostly the brain. That's what you have to change. Oh, I happen to have one here. This is what you've got to work with. Billions and billions of neurons, nerve fibers that are all jumbled up in the brain. And your job as an instructor is to change these neurons in some way or another by stimulating the brain through information and practice. Now, when the brain acts, you have to understand that nothing goes into the brain except electrical impulses. And then this causes electrochemical changes in these neurons, and that causes thousands and thousands of other neurons to fire, that is, to discharge their electrochemical charge. And as you practice something over and over again, the brain changes. Now, where is the information stored, or where is the learning stored? This is basically what a brain looks like. Well, it's stored in the chemicals and in the fibers themselves, in these neurons. That's where it's stored. You see, there are no cubby holes in the brain where things are neatly packaged. What there are neurons, and your job is to make some changes there. Now let's try to dispel a misconception, and that is this. The brain is not like a computer, no matter what you happen to hear. For example, a computer can recall information instantly in less than a millionth of a second. Does that sound like how your brain works? A computer retrieves information, that is, gets information out in exactly the same way it went in. In other words, it doesn't forget anything. Does that sound like the way your brain works? Not only that, but a computer can move information from one place to the other. Can you do that? So you see, there are no cubby holes in the brain. What there are neurons that are receiving electrical impulses through the eyes, the ears, the nose, and that somehow get stored and operate in terms of probabilities, so that the more you practice something, the higher the probability becomes that a certain pattern of neurons will fire and that you will be able to perform the new habit. So that's mainly what you have to work with, brains. Now, over the years, learning scientists have learned quite a bit about how learning functions. And what we've done in this module is taken a number of the more important principles and translated them into application rules. So you won't have to do that. These are rules which, if put into practice, will cause your instruction to be more effective. We've grouped the principles into 6 groups, arbitrary clumps of application rules. You'll find them on pages LP 12 to LP 25. The categories are not mutually exclusive. For example, principles in the practice category not only act to strengthen performance, but also to enhance memory. Never mind. These are just clumped to provide advanced organizers for you and make it easier for you to get at them. Now, in this module, there are going to be 2 activities. First activity will be what you do to prepare for the second activity. Brilliant, right? How about that? The first activity will be to collect out of your own memory and out of the memory of other people examples, illustrations, experiences that illustrate the correct or incorrect application of one of the application rules. If you've had any psychology, you'll recognize this as a concept formation procedure, a procedure for helping you to learn the boundaries between examples and non-examples of a concept. So that's the first activity. That will prepare you for the second activity, which is the learning principles discussion, the LP discussion. And there, somebody will describe an experience, and then your job will be to decide whether that experience is an example of the principle that is alleged, or whether it is a non-example of the principle being talked about. So those are the two activities that you'll be engaging in. So now, here's what to do. For as many of the application rules as possible, dream up from your own experience, your own memory, some experiences that you think illustrate the correct or incorrect application of that rule. Let me show you an example or two out of my own experience, just to show you how you might go about it. You may want to find the quick ID pages at the back of the module before we proceed. Let's look at principle P1. Make trainees actually practice the skills called for by the objectives. I remember in graduate school, because I was a psychology major, naturally I had to take lots and lots of statistics and mathematics courses, right? But I remember one statistic course where we got practice. We practiced every day. Practice, practice, practice. Somebody would say, do an analysis of variance. Yes, sir. We would turn that analysis variance crank like you wouldn't believe. And we did the same thing with the other statistics. We were whizzes at operating those statistics. Then at the end of the course, somebody said, all right, suppose you had a group of data in this kind of an experimental situation. Which statistic would you select? And we said, Well, it turns out that we had a lot of practice in applying the statistic, but we didn't have any significant practice in selecting a statistic. So for this application rule, make trainees actually practice the skills called for by the objective was correctly applied insofar as performing statistics was concerned, but it was incorrectly applied insofar as being able to select statistics. We didn't get the kind of practice that we needed. All right, now let's look at P2 over here. This says, allow trainees to practice only after they can recognize when they are doing it correctly. I remember talking to a couple of fathers who said, proudly by the way, you know how I taught my kid to swim? You got it. I threw him in the river. How's that for cleverly designed instruction? Now look at this application rule again. Allow trainees to practice only after they can recognize when they are doing it correctly. There wasn't any instruction or modeling to help these kids to recognize when they were doing it correctly. They didn't even know what to do, except blubber and try to keep on breathing. So that was a misapplication of that principle. One more example. Here on the application rule F2, make sure that feedback is not delayed or distorted. I remember courses wherein I would take a test and then not get the test back for over a week. So the feedback, such as it was delayed, far beyond the time that it was going to do much good. And then the feedback was a label. It was just a grade, you know, A plus, B minus, C minus, or whatever. So that kind of feedback was distorted in the sense that it didn't help me to know what to do. It didn't even tell me whether I was any good. All it told me was that I was better or worse than the rest of the people in the class, because those kinds of letter grades simply compare your performance with other people's performance. It doesn't compare your performance with a criterion. So here was another instance where an application rule was misapplied, that of making sure that feedback is not delayed or distorted. Now, once you've collected as many experiences as you can from your own head, then get into a discussion with a couple of other people and collect some from their bucket. That will prepare you for the LP discussion, during which you'll practice recognizing whether or not experiences or situations do or do not exemplify a particular application rule. And that's going to help you to look at instructional situations in a new light, and it's also going to help you to be able to troubleshoot existing instruction a whole lot better.